Welcome to the Tech Art Simplified Series. I'm Burk, and today we're going to build this dynamic waterfall shader in order to learn about global masks in Unreal Engine. Creating masks and controlling UVs are most of what we're going to do in a material shader, and there's so much power in each of these subjects that I split them into two videos. Today we're focusing on global masks. When I say global mask, what I mean is any mask we can generate that is not reliant on UVs. In this video, we'll look at the anatomy of a material graph, the basics of masking, global masks, how common math nodes work for combining, and then we'll clean up our graph for reuse, and at the very end I'll add a bonus node setup that'll help push the polish of the waterfall just a little bit further. If you'd like to follow along with the demonstrations, are curious about how things are put together, or just want to support this channel so that I can make more videos like this, I've made the project with everything that I show here available for just $5 on my Gumroad. The link will be in the description. Okay, let's talk about the anatomy of a shader. A common setup for a material shader are textures and masks connected, fed into an applier, and all of that leading to a final output. Not all graphs need all of these elements, but they're good keys to look for when you're trying to understand a graph. Let's talk about how each functions. Textures control the visual style. Masks control where textures are applied. Connectors combine masks and textures. Appliers translate that for use in one of the outputs of the results node. Although textures and masks can look complex, their setup is fairly simple. There are a set of controls for an alpha or texture with adjustments at the end for final tweaking. Most of these nodes are exposed as parameters in the material instance. When I was first introduced to parameters, I thought they were something more complex than the nodes that I was using before. But all a parameter is a node that's exposed in the material instance for manual control by the artist. The four most common parameters are scalars, used to control a single value, vectors, which can be used for colors, coordinates, directional vectors, or simply grouping values, static switches, which can be used for turning features on and off or debugging, and texture parameters, which allows the artist to control the alpha or texture maps used in a graph. It's important to be conscious of image type because the texture node is very picky. That was a really quick overview of the anatomy of a shader, but don't worry, we're going to cover each of those topics more in depth throughout this video, with the exception of the texture parameter that we'll cover in the next video. Okay, without any further ado, let's get into Engine. First things first, let's set up our scene. Here we are in the default third-person template. I'm going to press G to hide those icons, and then we can head to this back wall. If we move this quarter cylinder over 2 meters and this quarter cylinder over 2 meters, we can make a nice space for our waterfall. I'm going to use two shapes to build this waterfall so that we can see the power of global masking in Unreal Engine. The first shape we can use is a cube. If we scale it 4 on the Y, 4 on the Z, it'll make a good base to our waterfall. Pro tip, to move things a little quicker in Unreal Engine, if you hold Control and then left click, you can move it on the X axis. If you right click, you can move it on the Y, and then if you left and right click, you can move it down on the Z axis. So to get the rounded top to our waterfall, we can use this quarter cylinder. If we hold Alt, click and drag, we can duplicate it. And then pressing E, we can quickly move into rotate. Then we can scale it down 3 on X, 3 on Y, and 4 on Z. And then same way, we can move it into place. Let's lift these two up a little bit higher. And there we go. We have the base to our waterfall. Now let's build our material. Okay, first things first, let's create our material folder. And inside of our material folder, we can just create a folder called waterfall. If we want to get really organized, we can create a master and instance folder, but since we're only doing this, I'm just going to create a waterfall folder. And then we'll create our material instance in here. First, we'll create our master waterfall, and then straight away, we'll create our material instance, mi underscore waterfall. And then we can just drag our material instance onto both of our meshes and Control-Shift-Save. It's good to get in the habit of Control-Shift-Saving anytime that you make a significant change in Unreal, because you never know what's going to crash and it is a bummer to lose stuff. All right, let's dive into our waterfall and get started. Baseline, what we'll need for a waterfall is 2 colors, a way to blend between those 2 colors, and then a way to control how that blend is happening. So we'll use 2 vectors, a lerp and a smooth step. The first vector we can call water. The second vector we can call foam, and then we'll get our lerp and our smooth step, connect them all up. And our water we can just make any blue, and our foam we will make white. All right, now before I go any further, I'd like to explain what the lerp and the smooth step are going to be doing for us. Let's talk about masks in Unreal Engine. It's similar to creating a mask in Photoshop, where white is yes, black is no, and gray is kinda. But we're talking to computers and they like numbers, so white is 1, black is 0, and every value between is a very specific kinda. The lerp node helps us make use of that information and maps our A input to 0 and our B input to 1, essentially turning A into the background and B into the foreground. I know it's confusing because B sounds like it would mean background, but it actually is short for B in front of the other color, so the more you know. But here is where we run into some trouble. Lerp can actually step beyond 0 and 1 and distort our input. So when we apply our lerp to this noise, it's not our expected result. And that's because Unreal only shows 0 to 1 when it displays values. So we can have values beyond that range hidden in our whites and blacks. A saturate node can solve this problem by clamping our values between 1 and 0, but what if we want more control? Enter the smooth step node. It can be really helpful to visualize masks as peaks and valleys because then we can see our true values. Here we can see what our noise actually looks like and where the saturate node is cutting it off. If we run our noise through a smooth step node, we can actually control where we want to map our 0 to 1 gradient to and get a lot more dynamic result. Here you can see that as we change our minimum and maximum values, we can isolate or expand levels within our noise. And if we flip the values, we can even invert our noise. The smooth step node is pretty epic. Okay, now that we have our first applier set up, we need to build our first mask. Our first mask is going to be based on vertex normals in world space. And in order to build that, we're going to need a vertex normal world space. We're going to need a dot product, and we're going to need a directional vector. And we'll run all of this into our smooth step. All right, let's take a look at what's happening here. A quick note on vectors in Unreal. A vector is just a group of 2 or more numbers. Each position these numbers take means something specific to Unreal based on context. The first position will always represent red or X. The second position will always represent green or Y, and the third position will always represent blue or Z. And this is true as long as they remain in a group. Okay, now to our demo. Vertex normals are directional vectors, which simply means a direction based on an XYZ coordinate mapped from -1 to 1. And when we visualize these in Unreal, it combines the two meanings of a vector and gives us this beach ball looking effect. When a vertex faces directly in the positive direction, it has a value of 1. So X becomes red, Y becomes green, and Z becomes blue. If the vertex is perpendicular to those directions, its value is 0 or black. And it remains black as it turns in the negative direction because, remember, Unreal only gives us a visual for 0 to +1. If the vertex normals are based in world space, the object will always look the same because its transforms are ignored, which is going to help us for masking across multiple meshes. But if we switch to local space, you can see how it follows the object's local transforms. What our dot node is going to allow us to do is to create a mask based on a direction that we choose. So as I walk around on this controller, I'm telling the material to check what direction I'm located in. And where that direction matches the normal direction, it gets a value of 1. And as it gets perpendicular, it turns to 0, and then to -1 when it faces entirely away. And here you can see the limitations of the tool. The mask is created based entirely on direction, so only where there's a rounded transition will you get a smooth texture gradient. And this can lead to some cool or annoying effects, as you can see with this noise applied to these shapes based on world and local vertex normals. Now let's bring in a couple more nodes and start playing with our waterfall. We'll just bring in 2 scalars. We'll call this directional SS for smooth step min, and then I'm just going to copy paste that, change this to max. I want to make sure that we set our default value on the max to 1, and then we can just plug this all up. So in our scene, now we've got this bright blue, beautiful waterfall. If we go into our material instance, we can start playing with our values. So first things first, let's actually add our mask by controlling our directional vector. Remember, RGB corresponds to X, Y, and Z. So the first thing we'll do is we'll bring in some of our B value. And you can see it's already bringing in what looks like some specular coming over the falls. And then we're going to want to pull it backward on the X. And I find that we want to have a little bit overlapping on that flat plane. And what we can do is use our smooth step to clamp that value and just target the peak. Now, what we can do with the smooth step as well is if we increase the max, it's going to fade that out. So we can control how strong that gradient is. I think let's actually pull the X forward a little bit more and drop the B. So it creates kind of a subtle mask that we can use to fake some specular shining off of the top of our falls. Now to create some fun with the base of our waterfall, we're going to use a world space position node. So let's clean this graph up. We can disconnect this for now, and we'll bring in our absolute, our world's position. And we could bring out our XYZ and get a component mask and mask out just to our B or Z value. Or the absolute world position node is very helpful. It just gives us a Z. So we can pull this out and we're going to add a divide to that. I'm going to give it a big number like 100. And then we're going to plug this into its own smooth step node. We'll create two new scalars. We'll call this position SS min, copy paste that, max, and set our default value to 1, plug these up. Now before we start playing with this one, let's take a look at what it's doing. Like a Vertex normals node, position nodes map out the XYZ coordinates to RGB values. And like the local vertex, the local positions will follow the object's transforms. The world position won't follow these transforms, and it gives us the effect that the object is actually being pushed through the material. Here, I'd like to make a note of two things. The first is look how hard the mask lines are. Unlike our directional vectors that are mapped from -1 to 1, positions are based on location, and since Unreal counts location in centimeters, our mask values get really high really fast, which is why we added the divide node to our setup. The second is that since these masks are based on position, the shape of the object doesn't change the shape of our masks. As you can see on these objects, the 3D noise has no distortion. And here you can see how our objects are essentially being pushed through the noise. This is really helpful if, say, you're trying to create a waterfall effect across multiple meshes. Okay, now that we know what's going on, let's start making changes to our waterfall. So you can see here, as we increase our smooth step max, our mask is creeping up our waterfall even into the second mesh. Let's bring it back down. And then as we increase our smooth step minimum, we are clamping that gradient. So you can probably see that the problem we're having right now is that our mask is inverted. So we have two options. The first, we could just invert these values, and then we've got our inverted mask. Or to make it more intuitive for the future artists, we can go into our material, and just after our smooth step, we can add a 1- node. A 1- node does exactly what it sounds like it's going to do. It's just going to flip our values. Make sure we apply and save. And now, if we go back, our mask has been inverted. So let's just bring this up a tiny bit. I'm gonna fade it out a little on the bottom, bring it negative, and I think that's good. All right, that looks great for the base of our waterfall. Now let's combine our two masks, clean up our graph a little bit, and make our material instance a little more intuitive to use. Okay, the first thing I'm gonna do is reorganize this graph and leave some comments so I know what's going on. And then I'll get into the math a little bit later, but right now I'm just gonna use an add node to connect these two masks. Organizing parameters for material instances is pretty easy. You just select your parameter, and then head over to your details panel, and then inside material expressions, you've got your options for group, sort priority, and description. Unreal normally organizes these in alphabetical order, so I always add a number to the beginning of my groups so I can control how they show up in the material instance. For this node setup, I'm going to create two groups, base and foam mask. If you select multiple meshes, you can change these values for all of them at the same time. Sort priority allows you to decide the order of your parameters within each of these groups. And now we have our combined masks and our sorted material instance. If you're still with me, you're doing fantastic. We finally made it to our last global mask, the noise node. While the noise node could be considered a texture, I consider it both because I don't need any UVs to use it. And some of you may be concerned because the noise node isn't very performant, but there is a function that we can use that's only slightly slower than just a regular texture, so that's what we'll be using for this demonstration. You can see that our noise node is tiling way too aggressively, so in order to look at what it's actually doing, let's bring down the scale to something really low like 0.01. The noise node can lead to endless fiddling, so I'm just going to do a quick overview and then show you the values that we're going to use for our foam. So working down our list, turbulence just adds variety to the noise. For our purposes, we're going to actually leave it off. Levels controls how many steps are in our noise, so the more levels, the more detailed our noise will be. Output min and output max does exactly what you think. So you can control the lowest and highest values. If we set this to 1 and 2, we actually won't be able to see the values, but they exist. So make sure that you keep an eye on what your values are here, because I've had trouble with working with noise nodes before, and then I look at these values and I realize it's because they're way too high or way too low or outside of the range that I need them to be. Level scale controls how the noise scales at each successive step of the noise. 2 is a pretty safe number, so we're going to leave that at 2. And then for our purposes, we'll set levels to 2, output min to -1.35, and output max to 0.7. And we'll change our scale to 0.05. The last thing we're going to do is change our function to fast gradient so that we can get the most performant noise, because we're not looking for a lot of quality here. Now let's build our controls for this texture. Since it's operating in 3D space, our base is going to be a world position node. And then in order to tile it, we'll use a multiply. And we're going to want to shift it along an axis, so we're going to bring an add node in. For our multiply, we'll use a vector so we can control it on all 3 axes. We'll call this foam noise tiling. Make sure we set our values to 1. And then to make our artist's life easier in the future, we can actually change how these are labeled. So down here in parameter customization, We can make our R X, our G Y, and our B can turn to Z. And then we'll pull this into our multiply, move it out of our way. So when we make our noise shift, we actually want it to shift only on the Z axis to make it look like water's flowing down. So what we can do is create an append many, and this will allow us to isolate just our B value. If we don't put anything into these inputs, they'll stay at 0. So we'll bring in our time to B, and then bring in the RGB value to A, and we'll plug this into noise. And you can see that the noise is barely moving. So we're gonna need to add a multiply to crank that up a little bit. We'll call this phone noise speed. For now, we can set this at something like 20, and we'll adjust it later. All right, now let's take a look at what we've built. Okay, now we've got something that kind of resembles foam coming down a waterfall. One of the things that I really like about using the 3D noise for this kind of effect is the fact that at the top, we've got something that already looks like specular light because the noise is being pushed through the geometry. So first things first, let's get into our scaling because that's going to affect how the speed works. There's room for endless tweaking here, but the values that worked for me are 0.21, 0.58, and 0.067. And then for our speed parameter, let's set this to 38. Okay, this looks pretty good, but there's something that we can do to add a little bit more life. Let's hop back into our material and take a look at what it is. To make this foam seem more alive, we're going to add a second noise that's going to break up the first noise. So we'll just copy and paste our first noise. In our second noise, we can set these parameters. We'll switch turbulence on, we'll set levels to 1, output min we can set to 0, and output max we'll set to 1. We can leave the level scale alone because it's only got one level, so that's not going to matter. And our breakup's going to look best if it's flowing in a different direction than our first noise. So let's come down here, and instead we will plug our multiply in G, and we'll get rid of it from the B. Now we need to connect our two noises together. So let's look at how math nodes work as connectors. Here we have a simple linear gradient and noise switch. Let's step through our math nodes and see how these are affected. The addition and subtraction node will lift and lower the values evenly. In multiplication, the further a value is from 0, the more it will be amplified. And notice that it looks like it's rotating around the 0 value. Zeros essentially act as anchors for multiplication nodes. And the division node is the same, it just functions in reverse. The power node is really interesting. The first thing you'll probably notice is the curve that it creates in the values. And while it doesn't function exactly like a contrast node, it can be close enough in a lot of cases. One thing to note about the power node is what happens to the negative values. They immediately get clamped to 0. So keep that in mind if you're wondering why your negative values are disappearing in your setup. Now for the fun part. We've seen how math nodes work for simple values. Let's take a look at how they combine textures. Both of these textures are mapped from -1 to 1. If we add these noises together, you can see how they move through one another and interact. This node feels like there's a lot of life in the movement. If we use a multiply node, you can see the dark areas have a greater impact on the combination. As I'm moving around, you can see that they negate all the other values. The previous two nodes combine the noise in an equal way. And here, we're going to start to see a distinction. For division, our first noise retains its general style. Our second noise gets a really hard edge, and as we increase the value, we have this silver lining effect. Artistically, it's interesting to note the variety of edges that's created with a division node. And power also creates edge variety, but just with more subtlety. It's important to remember that my noise is mapped from -1 to 1, so if you're using a texture with a 0 to 1 range, your results will be more subtle. So before I connect these two noises, I'd like to have some adjustments for their outputs. The first one, I'd like to be able to lift and lower evenly, so we'll add you guessed it, an add node. And we'll call this scalar foam noise shift. And for the second noise, I'd like to control how large the breakup bands are. And the best way to do that is with contrast, so we'll use a power node. And we can call this foam breakup contrast. For combining these two noises, I really like the life that the add node had, so that's what we'll use. This is a great feature, but I don't know if all of our artists are going to want to use it. So we can add a static switch parameter to turn this feature on and off. We can call this foam breakup ? For true, we'll leave our combined noises in, and for false, we'll just plug in our original noise, and then we'll run this up to our base color. But before we go any further, because we copied and pasted our noises, these parameters are going to be linked. So let's go in, clean up, group, and sort our parameters. Now let's check out what we got. All right, let's bring in our second noise. Let's toggle it on. All right, so it's a little blown out, and that just shows the importance of setting our default parameters in our editor. It's because our breakup contrast is set to 0. So let's set it to 1.48, and we'll go in later and clean up all of our defaults and our ranges so that this is way more intuitive for our artists to use, and they don't have to deal with things like that. For our tiling, we can give it values of 0.01, 0.21, and 0.059. For our breakup speed, we'll give it a speed of 10. The effect is subtle, but I find that if something makes too big of an impact right away, it's going to be detrimental in the long run. It's a lot of subtle things built together that make really pleasing art. Now, let's button everything up and make this look like a real waterfall. We're so close. We just need two more things: to combine our foam mass and textures and to add some dark water to the base of our waterfall. So let's build our dark water noise first. All we're going to do is copy and paste our first noise setup, since we want it to flow down on the z-axis. We'll keep the scale and function the same. Let's leave turbulence off and set levels to 1. And in my fiddling, I liked 0.28 for the min and 0.93 for the max. I know it seems specific, but that's what I found. And then we can leave the level scale alone since we only have one level. Here, we'll get rid of the shift, and instead we'll use a smooth step for the adjustment. And then we'll run this into a lerp and set up our dark water color vector. And then we'll run this back into our original foam lerp. And now let's clean up, group, and sort these parameters. Now let's connect our foam masks and our foam texture. Again, I really like the life the add node had, so we'll use the add node to combine these two. And our values are going to extend beyond 1 and 0, so we'll just use a saturate node to clamp them. I want control over how much of the foam shows up, so I'm going to add a power node to control the contrast. And I'll just call this foam contrast. And then we'll connect this up. Now let's go into our contrast node and start playing with some values to get it set up for our future artist. First things first, the contrast is way too high, so let's set this default value to 1. And then in our details panel, you can see slider min and slider max, and this is where we can keep artists from either breaking the shader or going into values that no longer have an effect. So just as a test, let's see how high we can lift it before it maxes out. Looks like at about 100 it's maxing out, and that's kind of an extreme value. So something that we can do here, we drop this back down to 1, is we can add a modifier so that when your artist comes in, they don't have to push this to such an extreme value. So we can have this secretly multiply by, say, 10. And now, when we push our contrast, the change is happening at a much smaller value, which just makes artists feel a little bit more comfortable. And then we don't have to set a max so high. So we can, let's see, going negative does have a cool, it has the opposite contrasting effect, and our artist would probably like that. So we can set our slider min to -1. And now, as we push it, our max seems to be at about 1. So we can set our slider max to 1. And this is just the start of cleaning up our graph. Building a dynamic tool is only half the battle. To be a good technical artist, your tool also needs to be easy to understand, or as easy as you can reasonably make it. In this final polish step, it's important to think about the artist workflow and create groups that match the order your artist would approach the tool. To set default values that look good so your artist has a solid base to work off, and to set reasonable minimum and maximum values. This step allows us to protect artists from themselves, but it's important to not be overly restrictive here. Be open to artist feedback. If an artist really does need access to a wider range, give it to them. And then finally, consider debug switches. I've noticed that the subtle effect the noise has can be really hard to see. So one way that I can make an artist's life easier is I can add debug switches that allows the artist to isolate the noise and see exactly what changes they're making. In order to create our debugger, let's create a static switch parameter and call it debug noise. And we can run the result from our final lerp into the false, and we'll run its output into base color. And then we'll create another static switch parameter and call it isolate breakup. We'll run the combined texture into false, and we'll run just our breakup into true, pull the output of this node into the true value of our debug noise static switch parameter. This step isn't entirely necessary, but I do think this debugger adds a lot of value to this shader. I am not going to make you watch me set all these values, because I don't want to give you the impression that there is a right or wrong way to do it. This is your chance to practice this crucial tech art skill. So play with the shader you just built, push and pull parameters to find proper limits, and create groups you think will set your artist up for success. Heck, get rid of some of the parameters if you feel like they don't add any value and they just clutter up the material instance. This is part of the art in tech art, so enjoy it. But I won't abandon you entirely. Here are the default values that I use for the base of my shader. So there you have it, our dynamic waterfall shader. Tweaking these parameters can also get you a stylized version or this version that looks like massive falls. If you're curious about the exact values for these other shaders, they are included in the project file, but I'm sure with some tweaking you could just figure it out. Now, if we want to reuse the shader, we've got some problems. Since all of our masks are based in world space, if we change the transforms at all, they'll break. And if we want to use the shader in something, say, like a PCG graph, well, having our transforms based in world space just isn't an option. So I'm going to show you how to make this setup more versatile by making some quick edits to our mesh and engine, and then changing our shader from world to local. So the first thing we're going to need to do is find this mesh in our browser, because it's going to populate these changes to every mesh of that type. And we can duplicate it and then call it sm_waterfall. Then we'll go into modeling mode and select X-form, and we'll transform our mesh by rotating it to the same orientation as our original mesh. We'll scale it 3 on the X, 3 on the Y, and 4 on the Z again, and then we'll bake these transforms. Next, we can lift it up so that it matches the height of our previous mesh. And then this step is super important to make it work seamlessly. We need to change our pivot and drop it down to the floor. And make sure you click accept. Next, we'll go into mesh, and then we'll go to triangle edit. And here we're going to turn off points and edges so that we're just selecting faces. And if we go into advanced, we can untick hit back faces to make our marquee selection much easier. And then we'll just extrude this down to the floor. Now for our shader, we can just select our master and our material waterfall instances, and then duplicate both of them. And then we can rename the master m_waterfall local, and then the material instance mi_waterfall local. And then we can load up our material instance and just drag our new master material into general parent. That way it'll keep all of our settings and we don't need to rebuild a new material instance. Okay, once inside of our graph, it's pretty easy. We're just going to swap out every single world position node for a local position. Make sure on our position mask, you're dragging the Z out and not the XYZ. And then we'll go to our vertex normals and we'll get a transform node. And our source, we want to be world space, and our destination, we want to be local space. And then make sure we apply. Now we can just drag this material instance onto our mesh, and you can reposition this anywhere you want. This shader looks pretty good, but we can push it just a little bit further. It's time for that bonus setup. If we go into our master and we set our roughness to 0, you can see that the reflections are really flat and they kill the illusion of running water. So we can actually create an applier that converts our noise into a normal texture. First, we'll add our dark water noise to our combined foam noise. And then we'll bring in a prepare perturb normal HQ, and we'll run that straight into a perturb normal HQ. Then we'll take this world space output and we'll run it through a transform vector. And in this transform vector, we want our source to be world space and our destination to be tangent space. Now, in order to control the normal intensity, we could use a flattened normal and invert the scalar, but a more tech arty way to do this is to mask the R and the G and then run that into a multiply node. And we can call the scalar normal intensity. And then we can append the result of that to add a B value so that it's back to being a normal vector. And we'll just make that constant 1. And now we can run this out to a static switch parameter and call it use normals. And then we can create a 3 vector and leave the R and the G alone and change the B value to 1 to create a flat normal. And then the last thing we'll do is add this to a group. I'm just going to put it in the base group. Now, if we go back to our material instance, we can toggle our normals on. And there you go, our reflections are responding to our noise. You will notice some artifacting as we increase our normal strength, but that's just because we use the low quality noise. If that really bothers you, you can increase the noise quality and that'll disappear. Congratulations, you built this dynamic waterfall shader using no UVs at all. I hope this video is helpful to you, and I'd like to leave you with a few suggestions as you start to experiment on your own. Here are the 3 tips that I'd like to leave you with. The first, you saw me do this one a few times. It's really helpful to isolate the node you're working on by dragging its input into the base color. And the second is if you're going to tweak a graph you already like, make a duplicate. You don't want to break what already works. I have lost a ton of work before and it sucks. And finally, if you feel like you're getting lost in the weeds and start to feel overwhelmed, just take a step back and try and simplify the problem. The simplest solution is always the best. Well, that's it for part 2. In part 3, we're going to explore advanced UV manipulation and creating material functions. I hope to see you there. As always, work hard and play harder. My goal for this channel is really to help you succeed as a tech artist. And in order to do that, it's really helpful for me to know what you're struggling with and what parts of my explanations really connect best with your learning style. You can let me know by leaving a comment, or you can join our growing Discord community for more direct access. I'd really love to help you grow.